This video will explain the one sample run test for randomness. After studying this topic, students will be able to decide whether a sequence of event, item, or symbol is the result of a random process. So how does one know if the data obtained from a sample are truly random? So the procedure for investigating randomness are based on the number of nature of the run present in the data of interest. So what is run? Run is the sequence of like item. For example, we have A, then as one run, then we have the B, then there will be the second run. So we have the symbol item that is preceded and followed by an event item or symbol of a different type or by none at all. So without the randomness of a series, when there appear to be either too many or too few run. In this case, we can use run test to determine the randomness. So it will help us to decide whether a sequence of event, items, or symbol is the result of a random process. So, for example, a researcher interviewing 10 people for a survey, let the gender be denoted by N for male and F for female. Suppose the participants were chosen as follows. So for the first one, we have the male, and then continue by female, female. So in this case, we have 1, 2 run. So this is not random because we have too few run. We have only 2 run. Okay, and the situation number 2, we have the female, male, female, male, female, male, female, male, female, male. So in this case, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 run. So this case, it is not random as well because we have too many run. For situation number 3, we have the female as one run, male second run, female third run, male fourth run, and female as the fifth run. So we have 5 run in this situation. So for this case, whether it is random or not, we have to decide by using the run test. So before we start the run test, we must check whether it's fulfill the assumption or not. So the assumption that we do is the data available for analysis consists of a sequence of observation recorded in the order of occurrence, okay, which we can categorize into 2 mutually exclusive types. If the case that you have more than 2 mutually exclusive type, then it is the other method have to be used and won't be as discussed in this video. So we will let n as the total sample size, and n1 as the number of observation of the first type, and then n2 is the number of observation of the second type. So we have 2-tailed case and the 1-tailed case. So for the two-sided, the H0 will be the pattern of occurrence is random, and the H1 is the pattern is not random. So for case B, the H1 is not random because there are too few run, and for case C, it is not random because it have too many run. So the test statistic and the decision rules is shown in this video. The test statistic is R, which is the total number of run. Okay, like the situation 1, 2, 3, we have 2 run, 10 run, and 5 run. So the test statistic R is 2, 10, and 5. So for the decision rules, we will reject H0 in the two-sided case if your R, the total number of run, is less than or equal to the lower critical value, and the R is, or if the R is greater than or equal to the upper critical value. For the one-sided case, which is the H1 is we have few run, so we will reject H0 if our R is less than or equal to the lower critical value, and H1 have many runs. For the case C, we will reject H0 if your run R is greater than or equal to the upper critical value. So the critical value we can find from table A5 and table A6 in the Wayne W. Daniel textbook, that is the Applied Nonparametric Statistics, or we can get both lower and upper critical value from table M in Bruman Elementary Statistics textbook. In this video, I'm using the table M from Bruman textbook. Let's look at the first example. So, on a commuter train, the conductor wished to see whether the passenger entered the train is at random or not. He observed the first 25 people with the following sequence of male and female. So, this is the sequence, and we test the randomness at alpha equal to 0.05. So, for the first step, we set the hypothesis. It is random or not random. Random will be the claim, and we want to find the number of run. So the original data is like this. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 run. So R is equal to 10, and N1 is the number of female. Normally the N1 we will take the number of the first item that appears. So the first item appear is female, so we check the number of female. So we have 3 plus 4, 7, 8, and then we have 12, 15. N1 is equal to 15, and N2 we have 10. So N1 15, N2 10, R is equal to 10. So the third step, we have to find the critical value. We have N1 15, N2 10, and we check the table M in the Bruman textbook. N1 is equal to 15, N2 is equal to 10. So the lowest critical value will be 7, and the upper critical value will be 18. So we go back here, 7, 18, and we check the R is 10, is between 7 and 18. So it's not fall in the critical region, so we do not reject H now. And the conclusion will be there is not enough evidence to reject the claim that the pattern of occurrence of male and female under the train is determined by a random process. And for the example number 2, we have 20 people enrolled in drug abuse program. We want to test the claim that the age of the people according to the order in which they enroll occur at random. So random is the claim at alpha equal to 0.05. The data as follow. This is the data, the age, and then H now it is random, that is the claim. H1 it is not random, and then we find the number of run. To find the number of run, first we have to find the median of the data. So to find the median, we have to sort the data from small to largest, and then we find which one is at the middle, and the median is 27 plus 27 divided by 2, that is 27. So we compare the original data sequence, and then if it is greater than the than 27, greater than the median, then we will record it as A. So that's mean above the median. And if it is below the median, then we will use B. Okay, so 8 we will record at B, 36 we record at A, and the other also we record it. So after we record, we will find that actually we have B 1 run, A second run, B third run, A fifth, and then B 6th run, and then A 7 run, and then B 8. 2, 3, 4, 5, 6, 7, 8, 9. We have 9 run. So test statistic R equal to 9, and N1 is the number of B, that is 9. N2 is the number of A, it is 9 as well. So we find the critical value, N1 9, N2 9. So we will get that the critical value is 5 and 15. So we have the lower critical value 5, upper critical value 15. So we make the decision that the R is 9, that is between this 5 and 15. So we do not reject H now. So the conclusion is there is not enough evidence to reject the claim. that the pattern of occurrence of age of the people enrolled in a program is determined by a random process. So in this example, we test the age. We want to see whether it is greater than or less than the median. In actually, you can try to check the randomness by using mean instead of median. So we look at the third example. This example is get from the Rainy textbook. So table in the next page show the departure from a normal of daily temperature recorded at this date during November 1974. We wish to know whether we may conclude that the pattern of departure above and below normal is the result of a non-random process. Departure from normal of daily temperature recorded at this stage during November 1974 is as here. So in this case, those that is positive, that is above 0, then we will record as above A, and negative below 0, then we will record as B. So we write the hypothesis. Okay, and then it is random and not random, and we find the number of run. So we record the data here: A, B, and so on. Then we will find that it has 1, 2, 3, 4, 5, 6, 7, 8 run. So R equal to 8, and our N1 is number of A. We have 2, 4, 6, 8, 10, 20, 12, 14, 16, 17. So N1 is 17, N2 we have 2, 4, 6, 8, 10, 13. So we have 17 and 13. So 17 and 13, we find the table. We have 17, N1 17, N2 13, we have 10, 22. So actually the N1 N2 can be switched. Let's say we have N1 as 10 and N2 is 17, then it will be N1 10 N1 13, N2 17, then we have the 10 22. It is same. Okay, so the value of N1 and N2 can be changed. Okay, and we will have the 10 and 22 as the critical value, and we found that 8 is less than the lower critical value, so we have to reject H naught. So the conclusion will be enough evidence to support the claim that the pattern of the positive and negative departure from normal is not random. We can use the last sample approximation for run test when either N1 or N2 is greater than 20. So we can compare the computed Z that get from this formula with the one in table A2 in the Rainy textbook. So we have repeat the first example and extend the number of the no, this is something similar to the first example. So this is the data. Then we have the same H1 and H0, random, not random. And then we find the number of run. So look at here, number of run is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 run. Okay. And then we can find the N1 and N2. N1 is 2, 4, 6, 8, 10, 12, 14, 16, 20, 22, 23, 21, 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 21. Yes, 21. and the number of m is 2, 5, 7, 9, so it's 9. So we have the n1 is 21, n2 is 9, and we substitute all this value into this formula, and we will get that the z is equal to negative 1.6036. This is the test value. So if we find the critical value with the alpha equal to 0.05 and the z alpha over 2 will be 1.96, so the critical value will be the plus minus 1.96. so this is the plus minus 1.96, and this is the critical value region, and over here our test value is negative 1.6036, that is fall in the non-critical region, so we can make the decision that do not reject H now. So the conclusion is not enough evidence to reject the claim that the pattern of occurrence of male and female is determined by a random process. So this is the table that we use. That's all for this video. Thank you.